Welcome back to my channel today for the continuation of my 300B build. And you have to excuse my voice a little bit, got a little sore throat, but that's not going to stop us from continuing on with this project. The 300B tubes came in the mail. Yay! And these are a pair of the treasure tubes that have the black coating. These tubes are normally about $500 or $450 for a pair, and I found them on sale for right at $200. It's about $210, I think. And so I ordered a pair of these. I also have a pair of the budget Electro-Harmonix 300B tubes coming that I want to try in this amp as well. Since this is focused on being a budget build, we should see how the budget 300B tubes sound. As you can see, I think these tubes are going to scale really well with the size of these big Edcore transformers and finally look right. When I built this amp as a KT88, the transformers just looked out of place for the size of all the tubes that were in the amp. And I think with this layout, where I've got the two 300Bs, got a couple of Sylvania 2-hole SN7s, and I'm going to put the cathode bypass resistors here in the middle so that I can easily measure the voltage and also to help dissipate the heat above the chassis. We've got all the transformers bolted down now. We've got all the metal work done except for the tube socket holes drilled. And now that I've got the tubes, I feel comfortable at doing that. Once I get the tube socket holes drilled and the sockets installed, then I feel like I can really start figuring out where I'm going to put all the components underneath the amp. We are going to focus on what the work I've done on the power supply, how that's going to be laid out. I'm going to go over the schematic for the power supply so that you guys understand this split rail dual choke design that I'm going to be using with this amplifier, and also how I'm going to be powering up the heaters of the 6SN7 tubes. So I'm going to pause right here and flip the amp over so we can start diving into the underside and the power supply. Okay, first I want to show you how the AC wiring is done from the 120 volts coming into the amplifier. This is the hot lead that comes off the fuse that then goes to one side of this single pole switch. Off the other side of the switch is fed both the big power transformer and this filament transformer for the 6SN7s, and then both these transformers come back to the neutral and are connected here. That way we have a fuse between anything going on in here, and all the high 120 volt AC is in this one little corner of the amplifier, which helps keep any kind of hum that you would get from the line voltage just in this small little area of the transformer. The next thing I want to look at is the circuit for the heaters for the 300B direct heated tubes. We're going to be doing that with DC. This transformer has two 6.3 volt windings separate from each other. And the key here is that they are separate and they are not referenced to anything. They are this is a floating 6.3 volts AC. They each have their own full bridge silicon rectifier. After that, they have a 6800 UF 16 volt DC large filtering smoothing capacitor. Then this DC is run across the amp. Over near each of the 300B tubes, there's going to be this LT1085-5, which is a fixed 5 volt regulator. We're going to have one of these for each output tube, and on each side of it, soldered directly to it, is going to be a 10 UF and then a 22 UF to help keep this regulator from oscillating. So that's going to give us our 5 volts DC that we're going to be putting on the heaters of both of the 300B tubes. Next, we're going to look at the main B plus for the amplifier. This power transformer has 375 volts, 375 volts, center tapped high voltage winding. It's going to go to a 5AR4 tube, which is heated by this 5 volt AC winding this transformer also has, and the B plus is pulled off of pin 8 for the positive side. The negative side is the center tap of this power transformer. The first capacitor is going to be this large 33UF 630 volt Solene cap, it's a film cap. It does a really great job of dealing with being the first cap after the rectifier, and it's small enough to not damage the rectifier or arc it out on startup. The next thing in line is this 10 Henry large 75 ohm across it Ed core choke that's mounted on the top side in the front. It's a big blue one. And then after that, the rails are still being, or the power supply is still being shared by both tubes through this 100 UF electrolytic 500 volt capacitor. At that point, it becomes a dual rail system where each 300B tube has its own rail that's feeding it to help isolate them from each other. There's two 1.5 Henry chokes that have 57 ohms across them. They're mounted right here down at the bottom. And as I said in an earlier video, they share the same spacing with the choke on the top, so they can all be bolted down together. And then the laminations are at 90 degrees to each other, so there's no cross talk between them. Then each rail has one of these big 250U JJ 500 volt capacitors, and these are going to act not only as smoothing capacitors, but they also act as a reservoir for when there's a heavy current drawn by one of the tubes. It'll pull most of it from this large capacitor instead of trying to pull it from this shared power on this side. So it should act like a pair of monoblocks instead of your normal shared voltage power supply. The last thing that we have to deal with is the heaters for the 6 SN7s. And because they're going to have some elevated cathode voltages, we also want to elevate the DC offset of this 6.3 volt AC. So we're going to do that by pulling the center tap off of that transformer to this voltage divider with a small cap to smooth the ground side of it. And this will be connected to the B plus. And we'll adjust these resistors. I calculated a 620K and a 51K should get us around 35 volts. But I still got to figure out exactly what I want this DC offset to be. But this will help keep the heaters closer to the cathode voltages, even though a 6 SN7 can handle 100 volts between the cathode and the heater. That's not ideal. So we want to try to split the difference between the two sections to make sure that we get this DC offset as close to the average of the cathode voltages of the two sides. So, as you can see, we've got these two chokes mounted, and I'm going to zoom back in so we can look at these rectifiers a little better. So I decided to mount the two rectifiers for the 300B filaments here on the back of the amp. And up against the chassis is the rectifier itself, there and there. And then next is a little small plastic spacer. And then this 5-pin terminal strip is then bolted to it, held down by this nut. Get that center tap. And then between the rectifier and the chassis, I sanded the finish of this powder coating smooth, because it is kind of a rough cast, not rough cast, but it's kind of a rough finish. And I sanded it really smooth and then put some heatsink compound on the backside of these rectifiers, so that when I sandwich that whole thing together, they'll be using the back of the chassis as a heat sink to help keep them cool. And then I ran these wires from the pins of the rectifier up to this terminal strip. So these two pins and these two pins will be the 6.3 volt AC, and you can see I've already soldered these on. And then these two lower pins are going to be the DC that then will be run over from here into here to the 300B tubes, where the regulators will be bolted close to them. The other thing I was concerned about was the thermal cooling of the regulators. And after talking with some people online, several people thought that simply using some heatsink compound to the steel chassis would probably be enough. But I decided to get these little regulators, not regulators, but little coolers that will stand up off of the chassis and give some additional surface area for these regulators to stay cool. And I plan on putting thermal grease between these and the chassis, and then the regulator in this heat sink, so that it's all sandwiched together, and then drill a hole on each side of these through the chassis for maybe a 1/4 inch hole, so that the air can run as the heat rises, it'll be able to have a pathway out the top of the amplifier to help keep the regulators cool. So I think that pretty much covers the power supply and what I've done so far. I hope you're enjoying this video series. If you are, please subscribe to my channel and like the video. And we'll be back soon with more 300B fun. Have a great day.